Big idea number 3, polynomials and exponents. Lots and lots of review, so make sure you pay attention. But like I said, most of it should be review. First of all, when you have a negative exponent, it has to move. If it's on top, it has to go to the bottom. If it's on the bottom, it has to go to the top. So for instance, a to the negative 1, if you put that over 1, you got to move the a to the bottom, becomes 1 over a to the positive 1. Or like on the next one, 1 over m to the negative 1, you got to move the m up, m to the positive 1 over 1. Okay, when you move it, the exponents become positive. A to the 4th times a to the 7th. When you're multiplying, you actually add your exponents, becomes a to the 11th. M to the 6th over m to the 2nd. When you're dividing, you actually subtract your exponents, so you figure out where are they bigger. Well, they're bigger on top, so I keep the m on top, and 6 minus 2 is 4, so you get m to the 4th. X to the 3rd over x to the 8th, where the x is bigger. They're bigger on the bottom, so you put your x on the bottom. Subtract 8 minus 3, and you get 5. Nothing left on top, so you put in a 1. Power of power, p to the 2nd to the 8th. You actually have to multiply when you do power to a power, so it's p to the 16th. Y to the 0, anything to the 0 power is 1. Again, power to the power, you got to distribute that 2. So you get 3 to the 2nd, m to the 4 times 2 is 8. Well, 3 to the 2nd is 9, so you get 9m to the 8th. Distribute the negative 2 to everything in that. If the whole set of parentheses around it all, you have to do it to everything. So you get 1 to the negative 2 over 3 to the negative 2. Well, like I said, with negative exponents, you got to move it. So the 3 comes to the top, the 1 goes to the bottom, and then simplify. 3 squared is 9, 1 squared is 1. Okay, so those are just a quick reminder of the basic rules. Alright, so we're going to try one. I'm actually going to cross this next one off. But number 1, we're going to distribute that 4 to every single thing. So it's going to go 3 to the 4th, x to the, since there is an exponent, to the 12th. Y to the 4th. Make sure when you're doing a number, you're not taking 3 times 4, it's actually to the 4th. Okay, on the bottom, same thing, 2 to the 4th, not 2 times 4. Then you have x to the 4th, and y to the 2 times 4 is 8. Okay, 3 to the 4th is actually 3 times 3 times 3 times 3, which is 81. You have your x to the 12th, y to the 4th. Actually, get rid of those because we have to simplify those. Over 2 to the 4th is 16. Look at your x's, where are they bigger? Bigger on top. Subtract your exponents, so x to the 8th. Where are your y's bigger? Bigger on the bottom. 8 minus 4 is 4. Alright, simplifying radicals. When you're taking the square root of something, you're looking for pairs or perfect squares. So you can break this up into the square root of 48, square root of x to the 4th, square root of y to the 5th. You think of some perfect squares that go into 48. Another way to look at it is a factor tree. You can break that up to 4 and 12. 4 breaks up to 2 and 2. 12 breaks up to 4 and 3. 2 and 2. So you have a pair of 2's and a pair of 2's. If you have more than one pair, you times them together. So 2 times 2 would be 4. Put the 4 on the outside. The 3's left over, so that goes back in the radical. Then you have the square root of x to the 4th. You ask yourself, the square root means there's like a little 2 here. How many times can 2 go into 4? Twice. So you get x squared. So the square root of x to the 4th is x squared. If there was a leftover, I'd keep it in the radical. Square root of y to the 5th. You ask yourself, how many times can 2 go into 5? It can go in there twice, so you get y squared. And then there is a leftover, so you put it back in the radical. And then at the end, you have to put everything back together. So you had a 4. An x to the 2nd, a y to the 2nd, all on the outside of the radical. And then inside the radical, you had 3y. Okay, number 2, same type of thing, but now with a cube root. So if you don't know the cube root of negative 64, if there isn't one, you have to make a factor tree. So 4 times 16 is 64. 4 times 4 is 16. So if you look, you have a pair of 3 4's. Or a group of 3, I should say, 4's. So you pull that out, but since it was a negative 64, you get negative 4. Okay, and then if you think of the cube root of x to the 8th, you can ask yourself, how many times can 3 go into 8? It can go in there twice, and there'd be 2 leftovers, so inside the cube root, you'd still have x to the 2nd. For your cube root of y to the 15th, you ask yourself how many times can 3 go into 15? It can go in there 5 times. Okay, and then put everything back together. So everything that was brought out can go on the outside. So negative 4x to the second, y to the 5th. And then inside the cube root, all that was left over was an x to the second. Alright, so that's simplifying radicals. We're going to skip this one. Adding, subtracting polynomials, just combining like terms. So you look at your 2x to the third, you find the other x to the thirds and put them together. So you get a negative 4x to the third. So you get negative 2x to the third. When you're adding and subtracting, you don't change the exponents. Then you try to just find the next down. So x to the second would be the next one. So you'd have 3x to the second. You have negative 2x to the second, which makes positive 1x to the second. There isn't anything that's just x, so last but not least, you have your positive 4 and negative 5, which makes negative 1. Okay, so that's combining like terms. Now if you're subtracting, just make sure you go first and foremost in order of largest exponent to smallest. So we start with our 4x to the 5th. Nothing to combine with it, so you just bring it down. And then you'd have your negative 2x to the 4th. Remember, we're subtracting, so minus 3x to the 4th, which makes negative 5x to the 4th. Okay, and then you have your, after x to the 4th comes x to the 3rd, which is over here. And you have a minus 2x to the 3rd, which makes positive 2x to the 3rd. Then you look for your x to the seconds, and all you have is your 7x to the second. And then there is no x's in this one either, but you have a 1 minus 4, which is negative 3. Okay, so that's combining like terms. Multiplying polynomials, it's just distributing. So it's taking negative 5x to the second times 3x to the second. Negative 5 times 3 is negative 15. X to the second times x to the second is x to the 4th. Then if you distribute it to the 2x, you get negative 5 times 2, which is negative 10. X to the second times x is x to the 3rd. And then negative 5x to the second times negative 5. Negative 5 times negative 5 is plus 25, and then your x to the second. And then you check just to make sure you can't combine like terms, which you cannot in that one. On number 2, we're going to distribute the 4x and the 2 to every single thing. Start with your 4x, so 4x times negative x is negative 4x to the second. 4x times 5x is positive 20x to the second. And then 4x times negative 2 is negative 8x. And then you take your 2 times everything. So 2 times negative 8x is negative 2x. 2 times 5x is 10x. And 2 times negative 2 is negative 4. Okay, and then last but not least, just make sure you go back and combine your like terms. So you have your 2 separate x to the second. So put those together. So negative 4 plus 20 makes 16 x to the second. You have negative 8x minus 2x, which is negative 10x, plus 10x, so those all cancel. And then all you have left is your negative 4. Alright? Dividing polynomials, so you need to remember how to factor. So you have x to the second plus 4x plus 3. So if you factor that, a is 1, which is nice, so you just have x and x. You got to remember it needs to multiply to 3 and add up to 4. So plus 3 and plus 1. On the bottom you have x plus 1, and then when you're dividing, after you factor, you just try to see what cancels. So you have your x plus 1 and your x plus 1 cancels, so all you're left with is x plus 3. Okay, on number 2, the top is a difference of squares. So you have x squared minus 25, so the square root of 25 is 5. So you have x plus 5 and x minus 5. On the bottom, 3x to the second plus 14x minus 5. If you factor that, you need 3x and x. What you can do is you can take a times c and get negative 15 and figure out what multiplies to negative 15 and adds up to 14. Well, 15 and negative 1 do. And since I have a 3 here, I need to make this 15. So 3 times 5 makes 15. And then so minus 1 goes in the other one. And just to make sure, negative 1 times 5 would be negative 5. And then you look and see which ones can cancel. Your x plus 5 and your x plus 5. So on top you have x minus 5. On the bottom you have your 3x minus 1. Okay, so that's dividing polynomials. Number 3, same thing with dividing polynomials on top. Difference of squares, so square root of 9 is 3, so you have x plus 3 and x minus 3. And then when you're factoring on the bottom, 2x to the second minus 5x minus 3, you need 2x and x. A times c, so 2 times negative 3 is negative 6. So to get to negative 5, you would use negative 6 and positive 1. You got to use this 2 to make that 6, so we're going to times that by negative 3, so we put that on the other side. And then our plus 1 is on this side. Again, see what cancels, where your x minus 3's cancel. So you're left with x plus 3 over 2x plus 1. Okay, so that is dividing, that is polynomials and exponents.